Pappy Menon, VP of Product Management. I lead product management, design, and business development for Outshift, which is Cisco's incubator group. What I'm going to do today is talk to you a little bit about what we do at Outshift, what the charter of the organization is, and then get to the meat of the topic here on the Internet of Agents. What is it? Why are we building it? What are we building, the architecture of what we are building, and I'll talk a little bit about the collective, the Internet collective with whom we are building this together. So without further ado, let's dive right in. So I work at this organization called Outshift. This is Cisco's internal incubator group, and our charter is to look at the landscape of emerging technologies and figure out what is the next big meaningful opportunity for Cisco. And in doing so, there are two big areas of focus for us for the foreseeable future. One is agentic AI, and that's what I'm going to talk to you about today. The other, as you may have heard throughout the course of this conference, is quantum, particularly quantum networking and cryptography. So the big, hairy, audacious goal for us, for Outshift, is to empower Cisco to drive the Internet of Agents revolution. And what we mean by that is to create an open, interoperable Internet that enables agents to communicate and collaborate with each other to solve complex business and scientific problems. So it's meant to be for agent-to-agent collaboration, and it is meant to be quantum safe, because that is the other big transformational wave that we see sweeping across the industry, and we want to make sure that whatever we build for the Internet of Agents is quantum safe as well. And why do we think we need an Internet of Agents? We already have an Internet. Why do we need another Internet just for agents? The reason for that is we believe there is a fundamental shift in computing that's going on right now, and that is from deterministic to probabilistic computing. So far, any software entity, any computer system that you're talking to is largely deterministic in nature. If you think about microservices or APIs or containers or what have you, all of them are basically entities that behave in a more or less deterministic fashion. But AI agents are fundamentally different. Their behavior is non-deterministic and probabilistic, and which means that the way they communicate with each other also needs to have a new set of standards that support this kind of behavior. At the same time, even though they're non-deterministic and probabilistic in nature, they do need to collaborate and communicate to solve complex problems, much like a group of humans communicate, right? Like you have subject matter experts in different domains. They need to come together to solve problems, and agents need to do that as well. And these agents come from a variety of different places. They can be built by different vendors. They could be built on different frameworks. They could be running on different clouds. They could have different subject matter expertise, et cetera. And all of that needs to come together when you're solving when you're creating a multi-agentic system. So what we are talking about here is really a rethinking of the old OSI network stack model that we all know and love. We all have heard about the physical through the application layer stack, the famous OSI stack that powered the original physical internet. What we are talking about here with the agentic internet or the Internet of Agents is really something that layers on top of that. So there are semantic protocols and syntactic protocols that sit on top of this traditional OSI stack that enable agents to communicate with each other. And you may have heard some of the protocols that were developed recently, and I'll talk a little bit more about that in the slides to come, but you may have heard about MCP from Anthropic, the Model Context Protocol that came up, which was enabling agents to do tool calling, to reach out to APIs and tools and enrich their context. You may have heard about the Google A2A protocol that was developed for agents to talk to each other, and I'll address those as well. But these are the kinds of protocols that we are talking about. Semantic protocols that enable agents to exchange meaning and context, and syntactic protocol, which means that when agents that are built on different frameworks are talking to each other, their calls are formatted in the appropriate way. And the reason another reason we are having this whole debate about, or this the need to build a new internet, a new set of standards for agentic communication, is that agents have attributes of both software entities and of humans, right? They are non-deterministic and probabilistic. They communicate in natural language, much like humans do. But then their identities, the speed with which they scale, the ephemerality, the polymorphism that they exhibit is very much like a software entity. So you have attributes of both humans and software entities when you're talking about agents. And this is why we need an entirely new framework that addresses both of these. So you need to have a way to discover agents, to identify what their capabilities are, to be able to connect them securely, and then to observe what they do to make sure that they are doing what they claim to be doing. In this slide, I'm going to click through some of the build here, but the intent of this is to showcase some of the use cases that we are seeing out in the world on how agents come together to solve problems. So in the domain that we are in, the near and dear to Cisco and near and dear to many of you, I'm sure, is IT app deployment. If you think about the domain of IT app deployment, of an area that many of us are very familiar with, even in that area, you run across agents that are coming from different domains. So for example, I was looking at one of the booth demos, and they were talking about multiple agents coming together to solve this problem. So for example, you would have a ticketing agent that's from a company like ServiceNow. It needs to talk to agents from companies like Cisco, which have deep knowledge about your runtime environment, you know, your logs, your data, your network data, your security data. And all of these agents now need to come together to solve an IT app problem. If you have a problem in your network, you will need all of these agents to come together to actually solve that problem end to end. Similarly, if you take a slightly different domain, if you think about drug discovery or materials discovery, another area where there's a lot of disruptive innovation going on, you can imagine that you would have agents from general large language model providers like Anthropic, which would need to work with specific agents that have domain-specific expertise in areas like protein folding, for example, from companies like Evolutionary Scale. And then these would need to work with agents that do things like embodied agents, that work with robots to conduct experiments. And there are companies doing that, companies like Physical Intelligence. And all of these agents need to come together to solve, to discover new drugs. And this is why we need this common interoperable framework that will enable agents that are built in, across these different companies that are built on different frameworks to be able to talk to each other and be able to understand each other and solve these problems. And it's in service of this that we have built this collective called the agency. As you can see here, spelled slightly differently, pronounced agency, with the vision to build this open, interoperable Internet of Agents. And we truly believe in this vision because, if you look at Cisco's DNA, we were at the forefront of building the original Internet, which enabled machines to talk to each other. And we believe that it is the same approach that will serve every player in this ecosystem and enable them to unlock the most value. So we want to be part of this new, creation of this new Internet for agents to communicate. And this is why we are building it with this agency. Now, when we talk about common interoperable standards, that's not something that one company can do on its own. It is a collective effort. It is a collaborative effort, and which is why we are building this collective, which is an open source, first of all of this is being done in open source. All of the components, the protocols, the standards that we are building are available on GitHub. It's very permissive open source licensing, and we are building it with this collective of partners to build this together. There are components of it which Cisco has deep interest in, and we are building those pieces, but some of our partners are helping flesh out that vision and make it real. I'm going to talk a little bit. So from here, we are going to get into the nuts and bolts of what is it that we are building. So what is the architecture of what we are building with the agency? What is it that we are calling the Internet of Agents? But before we get into that, I want to quickly lay out a framework for describing what the life cycle of a multi-agent system looks like. So first of all, when you talk about building a multi-agent system, the first problem that you run into is what agents are out there today? So, I have this problem. I want to find what pertinent agents exist that I can leverage to solve my problem. That's kind of the discovery piece. And part of that is also how do agents talk about themselves? How do agents describe their own identity, their provenance, their capabilities in a way that they can be discovered? So that's the discovery piece. Once you've discovered what agents are out there, you now need to compose them into a multi-agent system. How do you describe that system? How do you enable agents that are built on different frameworks to now talk to each other? We talked about that semantic layer and that translation that needs to happen. That's the composition problem. Once you've discovered and composed your multi-agent system, you now need to deploy it onto your cloud infrastructure. So these agents need to run somewhere, they need to talk to each other, their actions need to be orchestrated, etc. That's the deployment piece of it. Once you've discovered, composed, and deployed your multi-agent system, there is the thorny problem of evaluating what they do. So agents, as we talked about earlier, they're non-deterministic in nature, they're probabilistic in how they behave. Well, how do you actually ensure that they're doing what they're supposed to do? And how do you ensure that they're not doing something they're not supposed to do? So all of that is part of that evaluate bucket. So we need to make sure that we gather the right traces, that we make sure we have the right guardrails, et cetera. So these are the 4 big stages in the life cycle of a multi-agent system. You have the discover phase, the compose phase, the deploy phase, and the evaluate phase. Now, with that in your mind, let's look at the architecture of what we have built with agency. This is kind of the core. This and the next slide go to the core of what we have built. So I'm going to spend a little bit of time here and go through all of these components one by one. First of all, off to the left, just to set the context here, off to the left, you have the 4 stages that I described for the multi-agent system lifecycle. And the architecture is on the right. So let's start with the top left corner, which is the OASF. OASF stands for Open Agentic Schema Framework. It's a framework that we have developed with our partners to describe agentic capabilities in a vendor-neutral, platform-neutral, standard manner. So it talks about, using the OASF, you can do things like describe an agent's identity, describe its provenance, who built it, how can you reach out to it, where do you find it, how can you talk to it, what are its capabilities and skills, what is this agent able to do, and what are the types of tasks that you can use it for. So everything that you need to know about an agent in order to use it for a problem that you may be wanting to solve and to put it as part of a multi-agent system is described in the OASF. Now, once you have an OASF entry describing an agent, that needs to live somewhere, right? It needs to live in a standard place where you can go discover it. That's the agent directory. And as you can see in this diagram here, you could have an agent directory that's running in org A and another that's running in org X. And the reason for that is the agent directory is designed to be a decentralized distributed service. So you could have multiple organizations all running their own directories, but sharing agentic metadata. And in fact, the agency, the collective that we have with whom we have developed this agent directory and all of these components, we are actually running a service today. So it's available if you go to hub.agntcy.org, you will see a live running agent directory that has a number of agentic entries in it. You can figure out how agentic metadata is presented, how you discover agents, and so on. We expect that at some point Cisco will have its own agent directory as well, which may have certain entries that are only for Cisco developers. So that's one of the things that the directory supports is you can have an enterprise directory for a company that has only the agents that their own developers use. But then they may have other agents that they develop that are for public consumption, and they can talk to other companies' public directories to be able to exchange that agentic metadata. So collectively, all of this network of directories will form the source of truth for agentic discovery. Much like the DNS is the source of truth for machines to talk to each other. So the agent directory very much functions like the DNS. It is for the Internet of Agents what the DNS is for the physical Internet. So collectively, the OASF and the agent directory together, they are addressing the discovery piece of that lifecycle. Going down from that, we go to the compose layer. And here you have the protocols that enable agents to talk to each other. And there, too, we have built several critical components that allow agents to talk to each other across frameworks, across platforms, in a neutral manner. One of these is what we call the IO mapper. That allows agents to exchange semantic context. So agents that are trained on different domains, that have different understanding of the world, they can exchange context and meaning for what they're doing using the IO mapper. Going down into below so you have the semantic layer, and then you have the syntactic layer. The syntactic layer is where you have protocols like Google's A2A. We also have, within the agency, we have our own protocol that we developed along Cisco and LangChain developed together. We call the Agent Connect Protocol, ACP, which does kind of the same thing. It allows agents to talk to each other in a way that, that bridges that syntactic gap between agents built on different frameworks. So if you have one agent that's built on LangGraph and another that's built on Crew, they will be able to talk to each other using ACP or using A2A. And in fact, one of the things that we are doing is talking to Google about the potential for converging these two. So that is an ongoing conversation. You can also see that over here, you have the foundation model protocols off to the left and right of this diagram. That represents protocols like the MCP, Model Context Protocol from Anthropic. That comes over here, which enables an agent to reach out to data sources or functions or tools and enrich its own context. So we support that 100% within our architecture. We have a component called the API Bridge Agent, which supports MCP natively. So, whenever we have, in general, this is the philosophy that we've been following. For us, it's the vision of the Internet of Agents is the main thing that we are focused on. When protocols emerge, as they have continued to do over the last few months, from various vendors addressing various parts of the agentic lifecycle, we figure out ways to either translate to those protocols, converge with those protocols, adopt them, or support them, as the case may be. So we are, we are an open house. We welcome all protocols. If somebody new, and this is not going to end. There's going to be new protocols that emerge as this space continues to evolve. When they emerge, we will figure out a convergence path with it. We will translate to it if need be. We will adopt it if we can, or we will figure out a path to converge with it. So far, we've talked about, so we talked about the discovery piece, we talked about the semantic and the syntactic layers. Now we get to where the rubber meets the road. And now all of this is getting deployed onto your cloud infrastructure, and these agents now need to talk to each other in real terms. The messages need to go across the wire, and the agents need to be able to exchange data and context. That's where we've built what we call SLIM. It stands for Secure Low Latency Interactive Messaging. And you can think of it as a messaging service that is optimized for agentic communication. Now, agentic communication has a certain specific shape to it. It has certain attributes. One, it needs to be fairly low latency. Well, not fairly low latency. It needs to be highly low latency, because you could have a human in the loop. So latency becomes very important. On the other hand, you have certain things like large multimodal state exchange, because agents communicate with text, audio, video, et cetera. It's large multimodal state that needs to be exchanged very quickly. So we have built a messaging service. It's based on gRPC, but it supports these different critical attributes of agentic communication. So it's a messaging service optimized for agents. It also supports things like peer-to-peer, one-to-many, many-to-many modes of communication. So it's really just a messaging service optimized for agents. That, with all of that, so again, discovery, semantic layer, syntactic layer, messaging layer, all of it optimized for the kinds of communication that we expect agents to have to do when they're part of a multi-agent system. This is a bit of an eye chart, but I think it is an important one. So yeah, please feel free to take pictures if you need to. But this lays out all of the different components, again, in more of a stack view of, more of a stack-based view. A couple of additional components here that I did not show in my previous diagram. Off to the left, we have the agent identity block. Now, that is another key piece of it. Agent identity is a big opportunity, but it's also a really, complicated problem to solve because of the issue that I mentioned earlier, which is that agents have attributes of both humans and machines. So you have, for example, the human on behalf of whom an agent is performing an action. So there is that kind of breadcrumbs trail to a human entity that you need to tie. But at the same time, agents can be ephemeral. They can scale up and down as needed. They can be polymorphic. You can ask an agent to do different things based on the context and based on who's doing the asking. So an agentic identity needs to encompass all of that and manage that within the life cycle of the agent. So that's the agent identity piece. That's something that we're working on. We'll have some announcements on that coming. We talked about the OASF, which is I'll just repeat that. It's an open framework for describing agentic capabilities and identity. The directory, which holds all of these different OASF entries for agents. The semantic layer, which is allowing agents to exchange meaning and context. So there is one component there that I did not mention in the architecture diagram. That's the semantic router. This is a component that allows you to create your multi-agent system with dynamic routing between the agents. So, when you set up a multi-agent system, you could have a very deterministic type of routing. You can say that agent A calls agent B, which calls agent C and D, etc. Or you could have the semantic router, which routes the calls dynamically based on the meaning of the call. So you could have agent A calling B, agent B, if the call is a certain meaning, or agent C, right? So it's a much more dynamic router. So that's a component that we are building. We talked about the syntactic layer, the Agent Connect protocol that we've built, the API Bridge agent. We talked about the messaging layer and SLIM. And then off to the right, those are a few components that we need to address as well. We have the observability and security components that we are building out. Again, when you talk about multi-agent systems, it's very important to observe what they're doing. Because again, these are single agents themselves are non-deterministic probabilistic systems. When you put many of them together, you've now increased the complexity of that system by an order of magnitude. And you need to make sure that these systems are performing the way you expect them to and that they are not doing something they're not supposed to. So gathering the right metrics, gathering the right traces, outputting that in the right way so that we can gather insights from it, having the right telemetry collectors in place. All of that is part of the observability, evaluation, and security components that we are building out. And with that, that is the entirety of the architecture. Quick word on the, do you need me to move back to the, if anyone wants to take a picture, I can move back to the previous slide for a second. And as I mentioned at the top, we are building this as a collective. We have about 55 plus partners today. And you can see there are logos of some of the key players in the agentic ecosystem today. You have players like LangChain and Llama Index, Galileo, MongoDB. I won't go through all of them. There are too many. And this is not a comprehensive list. This is just a sample of the logos that we have on our website. We have several large partners that we are talking to whose logos are not on the website yet. And that's, the talks are ongoing. But we are making progress with a number of the big players in this space as well. The goal here is to not have to create a fragmented ecosystem where everybody is reinventing the wheel. We are talking to all of these partners so that we have a common set of standards that lets us build these things with security and observability and a degree of confidence so we can deploy these multi-agent systems and have them perform what they're supposed to do. With that said, if you want to learn more about any of this, there are several ways to get engaged or to learn more. We have a website, AGNTCY.org, where you will see all of those logos that I described in the previous slide. But the most important place is the GitHub repository, because all of this is being done as open source. All of our partners are contributing through the open source repository, so it's all on GitHub. You can come take a look at that. You can contribute comments, issues, pull requests, what have you. So there are different levels at which you can join the collective. That's all there, by the way. The governance and operating model of the collective itself is also out in the open, and that link is there on the slide here as well. Please take a look at that and help build this new future together.